Hi everyone, I'm from SK Engineering Limited. Welcome to this demonstration of the Spectrum Pipelines suite of software. Spectrum Pipelines is a set of modules of design and integrity calculations for onshore and subsea pipelines. The software suite comprises 13 different modules, and each module is dedicated to different aspects of pipeline design. Today, I would like to give you a tour of the flow assurance module, which is used for hydraulics assessment and line sizing of single-phase liquid and gas pipelines. The module is activated by double-clicking the application file, which loads all of the software features. The graphic user interface has a very simple and user-friendly layout, which assists users with entering the input data on screen. Once input data is inserted and the user hits the Calculate button, the software solver calculates for the required parameters and outputs the results on screen. An Excel results file is also created, which supplies the profiles of flow assurance parameters along the pipeline length, such as pressure, temperature, erosional velocity ratio, etc. Let's take the example of a simple single-phase gas pipeline. The user has the option to select either one of the three parameters as an output. The other two parameters are given as inputs to the calculations. For example, if the user enters inlet and outlet pressure as input parameters, the flow rate can be calculated as an output. Similarly, if the user enters inlet pressure and flow rate as input parameters, the outlet pressure can be calculated as an output. The user needs to input the pipeline length, outside diameter and wall thickness, internal surface roughness, and inner coating thickness, if there is any. Thermal conductivity of the inner layer also needs to be entered, in case the user needs to calculate the overall heat transfer coefficient. The user has two options for overall heat transfer coefficient input, or U value. If the overall heat transfer coefficient is known, it can be entered manually. Otherwise, users can enter the specific input data for calculating the U value. The fluid model can be entered manually or calculated from its composition. Where the user knows the properties of the gas contents, it can be entered directly in the user input option. However, if the user needs to calculate the density of the gas, he can select the compositional option and enter the composition details of the gas. The gas composition comprises all of the hydrocarbon components and any inorganic components, such as carbon dioxide, hydrogen sulfide, hydrogen, and nitrogen. There is an additional option to enter heavier petroleum fractions, and the software also offers an option to enter the properties of 5 user-defined components. Depending upon the option selected, the user needs to enter inlet pressure, inlet temperature, outlet pressure, and/or flow rate. The software has an option to calculate the power required for a compressor, corresponding to the inlet pressure and flow rate. The user needs to enter the adiabatic and mechanical efficiency of the compressor for calculation of the total required power. The environmental parameter is needed to calculate the temperature profile and overall heat transfer coefficient. The environmental temperature comprises the ambient fluid temperature, current velocity, density, and viscosity. The ambient fluid could be wind in the case of exposed pipelines, or seawater in the case of subsea pipelines. Burial conditions of the pipeline need to be specified, which could be either buried or exposed. In the case of a buried pipeline, the depth of burial must be entered. Once all of these parameters have been inserted, the simulation is ready to run. All that remains is for the user to hit the Calculate button and the required outputs are computed. Let me load a model which I have already set up and saved as case 1. Once I run the analysis for case 1, the software calculates the flow rate resulting from my user-specified inlet and outlet pressure. The software also calculates the power required by the compressor. I have an added option to calculate the temperature, pressure, and erosional velocity profiles. A very similar approach is adopted for the flow assurance of a single-phase liquid pipeline. The main difference in the case of a liquid compared to gas model is that the compositional option is not available, and the user needs to directly enter the liquid fluid properties. Thanks for watching this demonstration of the Spectrum Pipelines Flow Assurance module. For demonstration videos of other modules, please get in touch with us at info@engineeringsk.com or enquiries@z-subsea.com. Spectrum Pipelines, making pipeline design and integrity smarter.